z to the negative fifth times 4z to the negative fourth. So the first thing that I'm gonna do just for this particular video is I'm gonna put both of these monomials in their complete form, meaning with a coefficient, a variable, and the degree of the variable. So this z right here has a 1. Let me get back to that one. Has a 1 in front of it. If you didn't know that, go back and watch my anatomy of monomials video. You cannot operate on monomials if you don't understand their makeup. That's like trying to do surgery, or matter of fact, would you let somebody do surgery on you if they did not know how the body works? The answer is hell no. So the same thing goes with monomials. There's no point of you trying to operate on monomials without understanding how they're made up. So make sure you go watch that video. But so there's a 1 in front of this z. And so now we got both of these monomials in standard form. So the first step is to multiply the two coefficients, which is 1 and 4. And so that's just going to be 4. Write that a little bit different. 4, we got 1 times 4. And the next thing that we have to do is combine these two variables. So we got z to the negative fifth times z to the negative fourth. When you multiply monomials, you keep the variable the exact same, and you combine the two exponents of the variable. So -5 plus a -4, meaning we're adding negatives to it, that's going to give us -9. And this right here is the answer for our monomial expression. Let's move on to the second problem. We got -8 z to the negative first power times x times z to the negative first times x to the fifth. So again, let's go ahead and put these monomials in their complete form. So we got -8. As a matter of fact, let me do this. Move the thing back up down. Make a little bit more space. Oh, hold on now. Oh yeah, wait. Can we do that? Would it let us do that? Oh yeah. Oh yeah, we did go ahead. Let's do it like that. We need some more space. All right, so we're going to put all of these monomials in their complete form. So we got -8 z to the negative first times 1x to the first, which is this right here. Again, please go watch that anatomy video if that's confusing to you. And then we got 1z to the negative first power times 1x to the fifth power. So now that we have all of these monomials in their complete form with their coefficient, their variables, and the degrees associated with those variables, now all we have to do is just combine all of the like terms, right? So we got -8 times 1 times 1 times 1. So that's just going to be -8. And then we got z to the negative first power times z to the negative first power. So of course we keep that variable the same, z, and we combine -1 and -1, and that's going to give us -2. And the final step is to combine the last variable and its exponents. The last variable is just x. And we got x to the first and x to the fifth power. So of course the variable stays the same, and we combine 5 and 1 to get 6. And this right here is our result. So moving on. Let me go ahead and shrink that thing down too, man. All right. So we got x to the negative third times y to the negative second times x to the negative second times y to the fifth. All of these variables have just a 1 in front of them. So I'm not going to put this in expanded form. I'm going to just save a little bit of time and space. So we got x to the third times x to the negative second. So again, when you're multiplying variables, you keep the variable the same and you combine the exponents or the degree of the variable. So we keep x right there, and then we combine -3 and -2, which is going to give us a -5. And we repeat that for the y variable. So we put the y variable there because it ain't going nowhere. And move the thing out of the way. See. And so we're gonna keep the y variable right there, and we combine the 2 degrees associated with that y variable. So we got y to the negative second plus, -2 plus 5, and that's gonna give us a +3. And so this right here is gonna be our answer: x to the negative fifth times y to the third. I'm gonna shrink this one too. All right. So we got z squared times x to the fifth power times -7 z squared. So I'm gonna put this one in expanded form. So again, there's a 1 in front of this z. So that's 1 z squared times 1 x to the fifth times -7 z squared. So the first thing we're gonna do is combine these coefficients, and that's 1, 1, and -7. So that's gonna leave us with a -7. Right, we combine this 1 times -7. That's going to give us -7. Next is to simply, now we're going to work with the z variable. We got z squared right here times z squared. And again, so when you're multiplying variables, you keep the variable and you add the exponent associated with the variable. So we got 2 plus 2, which is going to be 4, of course. So that's going to be the z variable. And there is no x variable nowhere over here, right? So we just going to keep that x variable just as it is. X to the fifth power. And this right here is our solution. Let's move on to what I believe is the final problem. Yeah. All right. So we got -9y to the -2 times x times -7y to the -2. So let's go ahead and put the thing in expanded form. It's gonna be -9y to the -2 times y to the -2 times 1x to the first times -7y times y to the -2. All right, so just like all the other problems, the first thing we're gonna do is just combine all of these exponents, right? So we got -9 times 1 times negative 7 again, because we're not looking at no variables right now. We're just looking at the coefficients. So we got negative 9 times 1. That's going to be negative 9. And so after that, we got negative 9 times negative 7. Two negatives, of course, are going to make a positive, and 9 times 7 is 63. So we're going to have 63 as a coefficient. And so now that we have handled the coefficients, let's move into the y variable. We got y to the negative second times y to the negative second. And so what we do, of course, is we leave the variable just as it is, and we combine the degrees that are associated with the variable. So we got a negative 2 plus a negative 2, and that means that we're adding negatives. I'll make a video about that in the future, but we're adding negatives. So negative 2, and then you add 2 more negatives, that's going to give you a negative 4. So this is going to be y to the negative 4th. And there is no other x variable, and so we just bring that thing down. And we're going to use the shortcut version. We're not going to put the coefficient and the degree. We've already dealt with that. So this is going to be the solution for problem number 5.